Hello, my friends on YouTube who want to learn about Python and Python web scraping. So welcome to another web scraping tutorial with Python. Today we are going to talk about regular expressions and why it's important to use regular expressions in web scraping. So like I said, regular expressions are very useful. Unfortunately, regular expressions, often shortened to regex, are often taught using large tables of random symbols strung together to look like a lot of nonsense. This tends to drive people away, and later they go out into the workforce and write needlessly complicated searching and filtering functions when all they need was one-line regular expression in the first place. So fortunately for us, regular expressions are not that difficult to get up and running with quickly and can easily be learned by looking at and experimenting with a few simple examples. So regular expressions are so called because they are used to identify irregular strings. That is, they can definitely say, yes, this string you have given me follows the rules and I'll return it to you, or this string does not follow the rules and I'll discard it. This can be exceptionally handy for quickly scanning large documents to look for strings that look like phone numbers or email addresses. So when we say a regular string, so what is a regular string? It's anything that can be generated by a series of linear rules, such as write the letter A at least once, append to this the letter B exactly 5 times, append to this the letter C any even number of strings of times, write the letter D or E at the end. So strings that follow these rules are shown in the after number 4, and there are infinite number of variations that can follow these rules. So regular expressions are merely a shorthand way of expressing these sets of rules. For instance, the line that we see on the here, REAA star, that's a regular expression for the series of steps that we just described up here. So the string might seem a little daunting at first, but it becomes clearer when we break it down into its components. I see a typo here, just so it's easier to understand. Let's play it again, excuse me. So when we break it down into its components, 2 A's followed by a star. So the letter A is written followed by A star, reads A star, which means any number of A's including 0 of them. In this way we can guarantee that the letter A is written at least once. 5 B's, there are no special effects here, just 5 B's in a row. And 2 C's in brackets with a star, that means any even number of things can be grouped into pairs. So in order to enforce this rule about even things, you can write 2 C's, surround them in parentheses, and write an asterisk after it, meaning that you can have any number of pairs of C's. Note that this can mean 0 pairs as well. So D pipe E in brackets, adding a bar in the middle of 2 expressions means that it can be this thing or that thing. In this case, we are saying add a D or an E. In this way, we can guarantee that there is exactly one of either of these 2 characters. So a note on when we are experimenting with regex, when learning how to write regular expression is critical to play around with them and get a feel of how they work. If you don't feel like firing up a code editor, writing a few lines and running your program in order to see if a regular expression works as expected, you can go to a website called as regexpal. Let me see if I can find it's there here, regexpal.com, and test your regular expressions on the fly. We'll use it. This website contains a lot of examples, top regular expressions. You can save your regex if you have tested it. You have a cheat sheet. So it's a very, very useful website. So definitely check it out. So one classic example of regular expression can be found in the practice of identifying email addresses. Although the exact rules governing email addresses vary slightly from email server to mail server, so we can create a few general rules. So what we are going through this example now, it's this is a regular expression for each of these rules, which is shown in the second column, sorry, the third column. So when we are building up a rule for searching for identifying email addresses, we can map it out like this. The rule number 1, the first part of an email address contains at least one of the following uppercase letters, lowercase letters, the number 0 to 9, periods, plus signs, or underscores. So you can see the regular expression on the right in the third column. The regular expression shorthand is pretty smart. For example, it knows that A to C means capital A to capital C means any uppercase letter, A through C. By putting all these possible sequences and symbols in brackets as opposed to parentheses, we are saying this symbol can be any one of these things we have listed in the brackets. Note also that the plus sign means these characters can occur as many times as they want, but must occur at least once. We're talking about the plus sign at the end. And rule number 2 for identifying email addresses is that after this, the email address contains the @ symbol. So @ symbol is fairly straightforward. The @ symbol must occur in the middle, and it must occur exactly once. So rule number 3 is the email address then must contain at least one uppercase or lowercase letter, which is identified as this, and it means we may use only letters in the first part of the domain name after the @ symbol. Also, there must be at least one character. And the next rule is that this is followed by a period, which is \period. You must include a period before the domain name. And the last rule is finally the email address ends with .com, .org, .edu, or .net. In reality, there are many possible top-level domains, but these 4 should suffice for the sake of this example. And this is written as in brackets .com with a pipe sign. So this lists the possible sequences of letters that can occur after the period in the second part of the email address. So by concatenating all of the rules, we arrive at this regular expression. So let's see how this works in our regexpal. If we go to our regexpal and paste it in, and I try to see if I can find it. Finds it matches 1, and let's say we try another domain. It matches. It matches. So back to this again. So when attempting to write any regular expression from scratch, it's best to first make a list of steps that concurrently outlines what your target string looks like. So pay attention to edge cases. For instance, if you're identifying phone numbers, are you considering country codes and extensions? So in the next table, we are going to just go over some commonly used regular expression symbols with a brief explanation and example. So this list is by no means complete, and as mentioned before, you might encounter slight variations from language to language. However, these 12 symbols are the most common and used irregular expressions in Python and can be used to find and collect most any string type. So a star means that matches the preceding character's subexpression or bracketed character 0 or more times. You can see the examples on the right. And plus sign means that it matches the preceding character's subexpression or bracketed character 1 or more times. And brackets matches any character within the brackets. In example, pick any of these things. Those are square brackets, and regular brackets are groups. It means a grouped subexpression. These are evaluated first in the order of operations of regular expressions. And M and N in curly brackets with a comma in between means that matches the preceding character, subexpression, or bracketed character between M and N times inclusive. So, and a caret in a square bracket matches any single character that is not in the brackets. And the pipe character means that matches any character string of characters or subexpression separated by the pipe. Note that this is a vertical bar or pipe as I mentioned, and not a capital I or L, a lowercase l. And dot means that match any single character including symbols, numbers, a space, etc. And as a character, caret by on its own indicates that a character or sub-expression occurs at the beginning of a string. And the backslash, it's an escape character. This allows you to use special characters as their literal meaning. And a dollar sign, often used at the end of a regular expression. It means match this up to the end of the string. Without it, every regular expression has a de facto dot star at the end of it, excepting strings where only the first part of the string matches. This can be thought of as analogous to the caret symbol. And the last one is a question mark and a exclamation mark. It means does not contain. This odd pairing of symbols immediately preceding a character or regular expression indicates that character should not be found in that specific place in the largest string. This can be tricky to use. After all, the character might be found in a different part of the string. If trying to eliminate the character entirely, use in conjunction with a caret and a dollar at either end. So the last one would give us back no caps, but symbols are fine. So a note on regular expressions. Theirs are not always regular. The standard version of regular expressions, the ones that we are covering in this tutorial, and that is used by Python and BeautifulSoup, is based on syntax used by Perl. Most modern programming languages use this or one very similar to it. Beware, however, that if you are using irregular expressions in another language, you might encounter problems. Even some modern languages, such as Java, have slight differences in the way they handle irregular expressions. So when in doubt, read the docs. And now let's go over to BeautifulSoup and regular expressions. How are they connected? So if the previous section of this presentation on regular expressions seemed a little disjointed from the mission of this tutorial, here's where it all ties together. BeautifulSoup and regular expressions go hand in hand, and when it comes to scraping the web. In fact, most functions that take in a string argument, for example, find ID, tag ID here, for example. We'll also take a regular expression as well. So let's take a look at the examples scraping the web page on our shop. Let me find that again. Our shop, which is here, we can see that we have a structure that there are many product images on the site that take the following form, which I try to highlight here, like image source equal to and etc. So if you wanted to grab URLs to all of the product images, it might seem fairly straightforward. At first, just grab all the image tags using .findAll with the image in brackets. But there's a problem. In addition to the obvious extra images, for example logos, modern websites often have hidden images, blank images used for spacing and aligning elements, and other random image tags you might not be aware of. Certainly you can't count on the only images on the page being product images. So let's also assume that the layout of the page might change, or that for whatever reason we don't want to depend on the position of the image in the page in order to find the correct tag. So this might be the case when you are trying to grab specific elements or pieces of data that are scattered randomly throughout a website. For instance, there might be a featured product image in a special layout at the top of some pages but not others. So the solution to look for something identifying about the tag itself, in this case we can look for the file path of the product images. Let's now try this code out. So I have some boilerplate from our earlier examples, which is similar, and I call this Python file scrape _shop _regex. You can call it whatever you like. So in addition to our boilerplate, we need to import regular expressions, which is import RE. And then we need to put a beautiful object in a variable, which will be a list. Image. And then we need to define the path. Here is where the regular expression comes in. Excuse me, \dot, and then we need / for escaping it. Image, / then gifts / image star \dot, and then we can loop over so it's escaping the two dots and building up the file path there, escaping the / there as well. Then we look for the source tag. Hopefully this should work. Excuse me. It's not, it's a comma. Let me try to restart it. again, I have a typo here. Typos. I don't edit my videos. I make mistakes. There you have it. So this prints out only the relative image paths that start with ... /image /gift /image and end in .jpg. So that's the output that we are seeing here. So to end this video, I'd just like to say a regular expression can be inserted as any argument in a BeautifulSoup expression, allowing you a great deal of flexibility in finding target elements. So I hope you have enjoyed this regular expression intro. This is a very short one. If you would like to play around with it, I will highly recommend you to go to the Python docs and see the regular expression section. It's a quite big one, but it's useful. So play around with it. So I hope you enjoyed the video. Please hit the like button, subscribe, or share the video, or comment if you like. And hope you have enjoyed this video, and I see you in the next video. Okay, bye guys.